Hello everyone, this is Dr. London. This is the final exam review. So number one is just some factoring, so let's remember how this works. If it starts off with x squared and no number in front of it, then you just need to find two numbers that multiply to the last one, 30 in this case, and that add up to negative 11. So that would be negative 6 and negative 5. So in this case, this just factors to x minus 6 times x minus 5, and that's it. If it were an equation, say it were set equal to 0, then you would set each of the factors equal to 0, and the two solutions would be x equals 6 and x equals 5, but they just asked for the factors, so that's all we have to do here. B is a little more complicated because the number in front of the x squared is a 2 now, so what we have to do is take the 2 and multiply it with the last number, 27, so we get 54. And now we're tasked with finding two numbers that multiply to 54, but when you add them up, add to negative 21. So negative 18 and negative 3 should do the job. So now this can be rewritten. Basically what we're going to do is we're going to rewrite the middle term as minus 18x minus 3x, because that's the same thing as minus 21x. So we have 2x squared minus 18x minus 3x plus 27. And then we want to form two groups and take the greatest common factor out of each group. So the first group we can take out a 2x, and we're left with x minus 9. And the second group, we want to take out a minus 3 so that what's inside the parentheses matches and leaves us with x minus 9. So our complete factorization here is 2x minus 3 times x minus 9. And that's it for part B of problem number 1. So for number 2 here, find the equation of the line that passes through negative 8, negative 4, and negative 4, negative 1. First we find the slope. So the slope formula is y2 minus y1 over x2 minus x1. So in this case, that's going to be negative 1 minus negative 4 divided by negative 4 minus negative 8. So that simplifies to negative 1 plus 4, which is 3, over negative 4 plus 8, which is positive 4. So our line has to look like y equals 3/4 x plus b, and then we want to plug in either pair of points for x and for y respectively. So let's use the first ordered pair. So negative 8 would replace y, and negative 4 would replace sorry, I got that backwards. Negative 4 would replace y, and negative 8 would replace x. The first coordinate is obviously the x coordinate, and the second coordinate is the y coordinate. So we have negative 4 is equal to 3/4 times negative 8 plus b. So we have negative 4 equals minus 6 plus b. You could add 6 to both sides, and we get 2 is the value of b. So our answer here is y equals 3/4 x plus, 3/4 x, not 3 over x. So 3/4 x plus 2. And just to check that our answer is correct, we can go ahead and plug in one of the points. Let's say if you plugged in negative 8 for x, we would have negative 6 plus 2, which gives us negative 4. So that's, it looks like it checks out. All right, so let's move on to the third problem. So for problem number 3, we're trying to write the equation in equivalent form using logarithms. So basically, we just want to make sure we recall the definition of the logarithm. So that basically says, let's say we have y equals log base b of x. This logarithmic equation is the same as the exponential equation b raised to the y power equals x. So if we take our equation, 8 to the y power equals 30, basically we're just kind of matching where everything goes. So y in this case is still y. Our base is 8, so we can write log with a base of 8 rather than b. And 30 is replacing x. So this expression y equals log base 8 of 30 is really what we're looking for. So that's just remembering the definition of the logarithm. Okay, so now we want to find the equation of the exponential function through 2 points. So we're going to use the standard form, which is y equals ab to the x. And then we want to plug in both points. And I recommend plugging in the point with the larger x value, in this case the second ordered pair with 1. So x and y are our variables, and a and b are the parameters we're trying to solve for. So if we get 325 would replace y, 0.8025, and that'll equal ab to the first. And the second coordinates, when you plug those in, you get 400 equals ab to the negative third. And then remember, the trick is basically you want to take ratios of this equation. That way a's cancel and you'll only be left with b. So you get 325.8025, that equal divided by 400, and that will equal ab to the first over ab to the negative third. That way the a over a is equal to negative, is just equal to 1, and the b's, you can subtract their exponents, so you'll get b to the first minus negative 3, which will just end up being b to the fourth. And if you plug the other side into your calculator, what do we get? We get some long decimal, but it will actually simplify when we take the fourth root. 0.814500625. So this number is equal to b to the fourth. So to solve for b, what we want to do is we want to take the fourth root of both sides. So if you take the left-hand side and raise that to the 1/4 power, you will get the same thing as if you raise the right-hand side to the 1/4 power. But the exponents will cancel on the right, leaving us with just b, and on the left-hand side we'll get, it comes out exactly to 0.95. So we found one of the two parameters, b. So we now know that our exponential expression has to look like y equals a times 0.95 to the x. So we just want to plug in one of the ordered pairs that we started with, and that will allow us to solve for a. So scrolling back up, probably 400 for y and negative 3 for x is going to be the easier of the two to work with, although either pair will work when you plug it in. So you can just divide both sides by 0.95 to the negative 3, and that'll give you the value of a. And again, multiplying or dividing by 0.95 to the negative 3 is the same as multiplying by 0.95 to the third power. So let's go ahead and figure out what that is. So that comes out to 342.95. So a is equal to 342.95. So our exponential equation through those 2 points is y equals 342.95 times 0.95 to the x power. Let's move on to the next. So for number 5, we want to solve this exponential equation for x. Since we see one of the sides has a base of 10, common log makes sense here. If one of the sides had a base of e, we would use natural log. If a base is neither one, usually it doesn't make any difference. Typically we're taking log or natural log. If the base doesn't work so well, we can always use properties of logs to solve it. But let's start by taking the log of both sides. Again, if you have an unknown in the exponent, that's a key sign that taking a log is going to be something you might want to do to solve. So on the left-hand side, they just cancel, so we get 7 minus 3x equals the log of 49. And then we can go ahead and just solve for x. So the first thing we want to do is subtract 7. So we have negative 3 times x is equal to the log of 49 minus 7. And then we want to divide by negative 3. And then we can use an approximation in our calculator to figure out about what that value is. So x is equal to the log of 49 minus 7 divided by negative 3. Let's put that in our calculator and approximate to 2 decimal places. And we get about 1.77. It's about what that comes out to. Again, you don't have to get the approximate value, but if you were using this for some type of application problem where you had a measurement or something like that, it would often be a good idea. And the accuracy that you want is going to depend on the accuracy of the measurements that you're using. So for number 6, we have a parabola. We want to identify the vertex and sketch a graph. So remember the vertex formula. Basically, the vertex formula says the x-coordinate occurs at negative b divided by 2a. So the x-coordinate of our vertex here is going to be what? It's going to be, let me put a colon there. So it's going to be negative b, so in this case b is negative 6, so it's going to be the opposite of negative 6 divided by 2 times 3. So this comes out to 1. So that's the x-coordinate of our vertex. The y-coordinate we're going to get when we plug in, so that's going to be 3 times 1 squared minus 6 times 1 plus 2. So the y-coordinate of our vertex is negative 1. So our vertex has coordinates 1 comma negative 1. The other useful point, we might want to identify the y-intercept. That'll usually give us another point. So if you plug in 0 for x, you get 2 for y. So 0 comma 2 is our y-intercept. So now we can sketch the graph pretty quickly. First we can find that y-intercept down here, or up here, at 0, 2. And then the vertex occurs at 1, negative 1, which would be this point right here. And we know the value a is equal to 3, the coefficient of x squared. So that means this parabola should open upward. If you look at the dotted line through the vertex, that's going to be the axis of symmetry. So that means if we have a y value of 2, 1 to the left of the dotted line, if we move 1 to the right of the dotted line, we'll also have a y value of 2. So this is the basic shape of our parabola. Again, you could plot more points if you wanted a little bit more accuracy, but that's just getting a quick rough estimate and looking at the vertex. Remember, the vertex, if this is an application problem, is going to represent either the absolute max or absolute min, depending upon which way the parabola opens. So for number 7 here, we want to perform this polynomial division using synthetic division. So remember the way to set this up. Dividing by x minus 4 means we want to put a positive 4 up here in this top left corner, then write the coefficients of the first polynomial above. So 5, negative 3, 8, and minus 4. There's no gaps, meaning you see x cubed, x squared, x in the constant term. If you had a gap, you'd have to include a 0. Like if you had x to the 5th and then you had x squared as your next term, then you'd have to account for some zeros for the 4 and the x to the 4th and x to the 3rd terms that were not appearing. But that's not happening here. So the way synthetic division works is we first drop this 5 down, then we multiply 5 by the 4 up in the corner to get 20. Then we add the second column. Negative 3 plus 20 makes 17. We do 4 times 17, which is 68. So then we add that third column. 8 plus 68 is 76. And then we do 76 times 4, which is, let's see, 280 and 24. So 304. And then we add the last column and we get 300. So let me just check to make sure I didn't botch up any of those. So they look good. So remember how this works. Basically, our last term is a remainder, and then we have a constant, x and x squared term. So basically, this is saying if you do the 5x cubed minus 3x squared plus 8x minus 4 divided by x minus 4, what this becomes is 5x squared plus 17x plus 76 plus a remainder of 300 divided by that divisor x minus 4. So anytime you're dividing by a linear factor, meaning something with degree 1, as we are in this case x minus 4, your solution is going to be 1 degree smaller. So we started with a cubic polynomial, we divided by a linear, so we got a quadratic polynomial plus a remainder of 300 over x minus 4. And that's it for number 7. Okay, so for number 8, we want to find the value of the 6 trig functions at theta. So we know the adjacent side is 9 and the hypotenuse is 12. So the first thing to figure out is this missing side. Let's call it y for now. So by the Pythagorean theorem, we know 9 squared plus y squared will equal 12 squared. So 81 plus y squared is 144. So if we subtract 81, we end up with y squared equals 63. Again, because these are just sides of a triangle, we can just take the positive square root. So we have y squared equals 63. So y is just going to be the square root of 63. So we end up getting y equals the square root of 63. So to figure out the 6 trig functions, we have our 3 basic ones: sine of theta, cosine of theta. So we're just writing down the ratios. We're not doing anything more complicated than that. Cosine of theta and the tangent of theta. So the sine of theta is the opposite side divided by the hypotenuse. So in this case, that would be the square root of 63 over the hypotenuse of 12. The cosine of theta would be 9 over 12, which we would typically simplify to 3/4. And the tangent of theta is the opposite, the square root of 63 over the adjacent side of 9. Now, the other 3 trig functions are the reciprocal functions. So the reciprocal of the sine function is the cosecant function. The reciprocal of the cosine is the secant of theta, and the reciprocal of the tangent is the cotangent of theta. And each of these, as long as you get the correspondence right, is just the flip. So cosecant of theta here will be 12 over the square root of 63. The secant of theta will be 4 over 3. And the cotangent of theta will be 9 over the square root of 63. So you're just taking the reciprocal of each of those different values. So just find the missing side and then identify what the opposite, adjacent, and hypotenuse are with regard to theta in this problem. Okay, so for 9, we want to solve for the missing part of the missing parts of the right triangle. We're given 2 of those parts here, the legs 9 and 40. So the first step is to find little c, then we want to find angles A and B. So we can find c by using the Pythagorean theorem. 40 squared plus 9 squared should equal the hypotenuse squared, which is c squared. So basically we get 1600 plus 81, so 1681 is equal to the value of c squared. So c will be the square root of 1681. So let's see if that comes out nicely. And it does, it's 41. So the square root of 1681 is c, which happens to be 41. Okay, so 41 is the value of c. So now what we want to do is we want to find so this is one of our missing pieces of information. So now we want to find one of the angles. Doesn't really matter which one, because once you know one of them, we know that a plus b have to add up to 90 degrees. We already have a right degree in the triangle, a right angle in the triangle, and if you add all 3 side angles together, you will get 180 degrees. So let's just take the tangent of b, let's say. If we do the tangent of b, that ratio should be the opposite side to b, which is 40, divided by the adjacent side to b, which is 9. So to find b, we just use the inverse tangent button in our calculator. So the inverse tangent of 40 over 9 will come out to an angle. Again, you need to make sure that you are in degree mode unless you want to be using radians for some reason. Typically for these, I'm just going to be asking you in degree mode. As you move into calculus, you're going to be using radians more and more. But for this one, let's just use degree mode. So let's do the inverse tangent of 40 divided by 9, and we get about 77.32. I'm just rounding to 2 decimal places. So 77.32 degrees, that's the value of B, angle B. So then A is pretty easy to solve for. A is just equal to 90 minus B, which is 77.32. So minus its complementary angle. So angle A is going to be, what is that? 22.68 degrees. So now we found all 3 missing pieces. So number 10 will be a similar one, but we'll have one angle and a side rather than just 2 sides. So the method of solution will be slightly different. Okay, so for our final question, question 10, we have given to us one of the sides, 17.38, and we're missing the 2 other sides, which we've labeled lowercase b and lowercase c, and we also need to find angle capital B. So angle B is the easiest thing to figure out first. Again, the 2 acute angles in the triangle have to add to 90, so we have angle B is equal to 90 minus 49. So right off the bat, we have angle B, which is 41 degrees. So we have that piece of information. Now we need to make use of our trig function to figure out the sides. So let's suppose we want to figure out C. Well, we know that the sine of the known angle there, 49 degrees, is going to be the opposite side, which is 17.38 divided by C. So we can cross multiply and get C times the sine of 49 degrees. That has to equal 17.38. And then we can just divide by the sine of 49. So we get the value for C. So 17.38 divided by the sine of 49 comes out to 23.03. So that's one of the missing sides. You could use Pythagorean theorem now to find the third side, but I'm just going to get a little more practice with trig, so let's use trig to find that last side. Again, we could use the same angle and side, but let's say we wanted to use tangent. If we use tangent, then we get the ratio 17.38 divided by b, and that will allow us to solve for lowercase b. So the let's go ahead and do that down below, or somewhere over here. Let's say the tangent of 49 degrees. That will equal 17.38, the opposite, divided by the adjacent, which is b. So following the same set of steps, b times the tangent of 49 will equal 17.38. So then b is going to be, we divide both sides by the tangent of 49. So we get b is 17.38 divided by the tangent of 49 degrees, which is approximately, let's see, comes out to about 15.11. So let me just do that below. And that's the last unknown, so 15.11. And that is that. So that's it for the test review. Hopefully everything is clear. If not, shoot me an email and I will answer any questions you might have. It's Dr. Lennon signing off.